Hi guys, welcome to week 10, functional anatomy, where we're going to be looking at nerve function and innervation. So we're going to start off by looking at some of the features of the nervous system. We'll talk about how movement occurs and how our reflexes occur. Then we'll have a look at some specific areas of the body and the different nerves in those areas and some of the key features of the nerves in those areas. All right, so let's start off with a brief overview of the nervous system. So if we think about the function of the nervous system, is it receives information from our environment, from our stimuli. It integrates that in the brain and the spinal cord, and then it responds. So receives, integrates, and then responds. And that ends up in us moving, catching a ball, kicking a ball, whatever it is that we're telling our body to do, all happens in that nervous system. So the nervous system's really two key parts. It's the central nervous system and the peripheral nervous system. Now, the central nervous system is made up of our brain and our spinal cord, whereas the peripheral nervous system includes our cranial nerves and our spinal nerves. So the cranial nerves are the nerves that go to and from the spinal cord up in your brain and in your head. So up here are all the cranial nerves. Then the spinal nerves go elsewhere in the body to our extremities and so on. And that's what we're interested in specifically today. So spinal nerves go to and from the spinal cord to our arms, to our limbs, to the rest of our body. And there's 31 pairs of these spinal nerves to look out for. Now, when the spinal nerves go down to the limbs, often because they extend from the spinal cord, they actually sort of tangle up and form these big complex areas which are called a nerve plexus, and then that extends down the limb. So these plexuses are what we're going to look closely at today. There's three that we're going to look at, but a nerve plexus is essentially this tangled web of the nerves before they extend down into the limb. So this branching network of nerves that supply our limbs. So before we get into looking at the nerve plexuses, let's take a closer look at the spinal nerves and how those spinal nerves actually work. So you can see this picture here. It's also in your lab book, and this is showing how one spinal nerve is attaching to the spinal cord. So the nerve is the yellow, and the spinal cord is that browny color in the middle. Now, we have sensory fibers. So I said that the function of the nervous system is to receive information, and it does this through our sensory fibers. And the sensory fibers pick up what's going on in the environment. They pick up the stimuli. They send that message through an afferent pathway through the dorsal root to the spinal cord. That message gets integrated, and then the response comes down through the ventral root via the motor fibers in this efferent pathway. So the sensory fibers receive the information, and the motor fibers respond to the information. And each of our spinal nerves connects to the spinal cord via a dorsal and a ventral root. So the sensory information goes through the dorsal root, whereas the motor information, which is going to cause that movement in our body, goes through the ventral root. So dorsal means back, ventral means front. So another word for dorsal and ventral is posterior and anterior. So that ventral root is anterior, whereas that dorsal root is posterior. So we can see the spinal nerves on our skeleton models, and they're represented by those yellow little bits of plastic that are sticking out there. So each spinal nerve is shown by those yellow bits of plastic. So we can't necessarily see the difference between the sensory and the motor when we're looking at it like this, but if we have a look at that model again a bit closer, we can see that the spinal nerve splits off into those two things. So the sensory nerve transmits the afferent pulses from a stimuli to the central nervous system, whereas the motor fibers end up transmitting the impulses from the central nervous system to the effector, be that a muscle, even different glands and hormones throughout the body. They get innervated by these motor fibers. So this is how this receiving of information, then the integration, then the response works in the spinal cord. Now, or in the spinal nerves. Now, something important to mention is that most of this is going on in the brain. So the sensory fibers send the message, that message goes up to the brain, and then we make a decision about what we're going to do, and then that decision gets sent down and the motor fibers end up performing whatever the action is. Now, that happens very, very quickly, but it's still a conscious decision. Now, when we think about a reflex is something that we don't think about. It's innate, or it's born in us. It's not a learned action. And the thing that's quite interesting about a reflex is that the integration never gets to the brain. So reflexes happen so quickly, and that's because we never make that conscious decision in the brain that we're going to do this. It all happens just in the spinal cord. The message never gets sent upwards. So when we have a reflex, and this is called a reflex arc, the first thing that we see is a receptor or a stimuli. So here we're seeing a pin being pricked into the skin. So that's gonna be picked up by the sensory nerves in the skin, specifically when it comes to touch and feeling this pin going into the skin. That's our mechanoreceptors. So those are the sensory nerves that pick up on that pressure. So they're going to send that message via the sensory neuron back to the spinal cord. There's going to be a really fast integration within the spinal cord that's going to send a message via the motor neuron to our muscle, which is our effector, to say, I need to move my finger because it's about to prick my skin and draw blood. So in our normal everyday movements, the brain interprets the stimuli and makes a decision. Whereas when we have a reflex, that message never actually gets to the brain, and it all happens within the spinal cord, which is super interesting. So let's have a look here. Another image that you can see. You're looking at a glass of water. So in the eye, the sensory nerves are called photoreceptors. So the photoreceptors are seeing the glass of water. They're sending that message back to the brain. The brain's making this conscious decision to pick up the water, and that's sending that via the motor fibers to the muscle to say, pick up that glass of water. Whereas if this was a reflex arc, we'd have that rapid involuntary movement that would bypass the brain. Okay, so let's have a look now at the first plexus that we're going to be talking about today. So I said a plexus is this complex network of nerves which sort of come together and supply the limbs. So the plexus that primarily supplies the arm is called the brachial plexus. And remember that term brachii, we saw it in biceps brachii, triceps brachii. It's referring to that upper arm area. So there's a reason that it's called that. Now, the brachial plexus, it's very complex. This is often a anatomy student's nightmare to learn what's going on at this brachial plexus. The good thing for us is though, the level of depth we're talking about today is quite surface level. So it's quite a complex topic, and you can see just how those nerves are sort of running together and moving around, and you sort of lose track of where's one going, what's happening there. And it becomes quite difficult to sort of be able to identify what's going on here. And you can see in these pictures, there's a lot of labels going on, so that adds to the complexity as well. But if you look at the picture at the bottom, that white stuff that looks like string cheese, those are our nerves, and that is the brachial plexus that you're looking there. So the brachial plexus comes from spinal nerves C5 to T1. So it arises from C5 to T1. So that means the spinal nerves that come off our C5 down to our T1 come together, they intertwine here, and then they go travel down the arm to supply the muscles of the arm. And it's actually quite a common site of injury, this brachial plexus, and you can feel it on yourself as well. So if you press into your neck above your clavicle, just to the side of that sternocleidomastoid muscle, which is that big muscle in the front of your neck, if you press in here, you can sort of feel all those stringy bits, and you're actually there feeling that that brachial plexus. So it's a bit yucky to feel, but it's interesting to palpate it. Now, I said that it's a common site of injury, and that's because if you're running, it actually happens a lot in like a rugby type sports, where if you're running, right, and then someone behind you grabs your arm and yanks your arm backwards, that's going to cause a big stretch right there at the sort of front of the neck, and it can sever or really injure that area. So it's not a good place to injure it. And if you completely injure it, like if you rupture that brachial plexus completely, you'll paralyze the whole arm. So it's not a good injury to have. Nerve injuries are always not nice. They're very, very painful. Anyone who's had something like sciatica or even a pinched nerve would know that feeling of that nerve pain, which is not pretty. And we're going to talk about sciatica soon. All right, so let's talk now a little bit about the nerves of the brachial plexus. So where these spinal nerves intertwine, then we have some specific nerves which come down our arm and innervate the muscles of our upper limb. So we have the axillary nerve, the musculocutaneous nerve, the radial nerve, the ulnar nerve, and then of course the median nerve as well. So each of these nerves supplies or innervates some different muscles of the arm. Now, we're often asked when it's face-to-face teaching, do we need to learn all of this? The answer is generally no, but we do recommend learning 2 to 3 examples of muscles that are innervated by each nerve, so that if you're asked to say provide 3 muscles that are innervated by the radial nerve, that you can do so. So important to sort of have an idea of where these nerves go, but it's not necessary to memorize these tables fully. So let's talk about the radial nerve, because that's an interesting one. Now, the radial nerve travels down the arm, and it's actually quite common if you fall asleep or you know, you've had a big night out and you fall asleep on a couch, or you've been lying on a couch too often and your hand is sort of like this, draped over the edge. This compresses that radial nerve. And when that nerve is compressed for too long, of course, it's going to impact the blood supply going to that nerve. So if you've woken up in the middle of the night and your hand is fully numb and you're slapping your hand like this, and it's like the biggest fright ever, normally that's because of a compression on that radial nerve. And they actually call it Saturday night paralysis, in the idea that, you know, you've had a big night and you've fallen asleep with your arm draped over the back of a chair or something, and it's caused that compression on that radial nerve that results in that pretty painful numbness, and then pretty severe pins and needles. So as the nerve regains the blood supply, the pins and needles begin throughout the hand and the limb, and then they go away quite quickly once that blood supply is back and good. The ulnar nerve is an interesting one. It's actually the nerve that makes up our funny bone. So you guys know by now that there's no actual funny bone, but it's the ulnar nerve that actually creates that sensation of when you hit your funny bone. So if we have a look at the ulnar nerve a little bit closer, what we're seeing here, the ulnar nerve is that blue line. And you can see the ulnar nerve passes just behind that medial epicondyle of the humerus, and it's quite superficial here. Like, I can feel that medial epicondyle quite well. There's not a lot of fat or muscle lying on top of this. It's very close to the surface, and that's why it probably gets hit a bit too often is because it's quite close to the surface. So if you bang your elbow on a wall, on a door, whatever it is, then that ulnar nerve's going to get that quick zap of compression and send that horrible funny nerve, funny bone feeling down throughout your arm. So the funny bone is where the ulnar nerve passes behind the medial epicondyle, where it's quite superficial. So it means that when it gets hit, then there's that compression of that nerve that sends that horrible feeling down your arm. Then we need to also discuss the median nerve. Now, we've heard of the median nerve before. Where have we heard of the median nerve? Can you remember? It was back when we looked at the wrist, and the median nerve was implicated in carpal tunnel syndrome. So remember how we spoke about carpal tunnel, the median nerve runs through the carpal tunnel. So when we have an inflammation of that area, it causes a compression on that nerve, which can result in those horrible nerve pain feelings through the hand and fingers. Now, the median nerve is actually also an important nerve because it often gets injured or slashed in wrist slashing suicide attempts. So horrible situation there. But often if people manage to survive that scenario, they can have real injury of that median nerve, and that can really affect the movements of their hand. It's a very common phenomenon that's seen. So those are the nerves of our brachial plexus: axillary, musculocutaneous, radial nerve, which is the nerve that makes your hand go numb when you're asleep, the ulnar nerve, which creates the funny bone at the medial epicondyle, and then of course the median nerve, which is implicated in carpal tunnel. Okay, let's move on to our next nerve plexus. Now we're looking at the lower limb, so we're going to talk about the leg here, and this is the lumbar plexus. So this is that network of spinal nerves that arise from the lumbar vertebrae and then supply our leg. Important to mention that the lumbar plexus goes down the front of the limb. So lumbar plexus supplies the anterior leg. And because what we're going to see in the next plexus we look at is that one supplies the posterior leg. So it helps you distinguish them a little bit. Lumbar plexus, anterior leg. Write that down somewhere. Now, the lumbar plexus specifically arises from L1 to L4 spinal nerves, and it actually lies in the psoas major muscle. So you can see on the location on the slide on your screen that this lumbar plexus would be right where that muscle is, and interestingly enough, it's literally within the psoas major. So that's quite interesting when it comes to that plexus. And we've got two main nerves that sort of run down the limb from this plexus, being the femoral nerve and the obturator nerve. So the femoral nerve supplies that iliopsoas and then all of our quadriceps as well, whereas the obturator comes down on the medial part of the thigh, and it gets its name because the obturator is actually the hole in the coxal bone. Let me see if I've got one moment. Yes, okay. So in the coxal bone, we have this hole here. We've never really talked about this before. This hole is called the obturator foramen. So the obturator nerve actually goes down through this hole, and it innervates the muscles on the inside of our leg, being our adductors and also the gracilis. So very important for those medial thigh muscles, being the obturator nerve. Okay. And then we have the sacral plexus, which is our final plexus that we're going to be talking about today. The sacral plexus is on the very similar spinal nerves as was the lumbar. So sacral plexus comes from L4 to S4, but it goes down the posterior side of the leg. So importantly, we need to remember lumbar plexus supplies anterior leg, sacral plexus supplies posterior leg. So L4 to S4, and that's the fourth sacral spinal nerve. And you can see in the picture there that there's some nerves coming out of those little foramina in the sacrum. Now, the sacral plexus includes two main nerves, being the sciatic nerve, which is the biggest nerve in the whole entire body. It's the longest and the thickest nerve in the body, and in its thickest spots, it can be as thick as your finger. So you've got a nerve about that thick in your bottom that runs down the back of your leg. The sciatic nerve splits off into two, so it travels down the thigh. Once it gets to around the knee area, it actually splits off into two, being the tibial and the common fibular nerve. So that's why in your lab books it's got those two parts to it. And then the other nerve in the sacral plexus is the superior and inferior gluteal nerve, which supply our glute muscles, so gluteus maximus, medius minimus, as well as the tensor fasciae latae. So two main nerves of the sacral plexus being the sciatic nerve and the gluteal nerves. Now, the sciatic nerve is a very finicky nerve, and a lot of people get pain through that sciatic nerve, and often it appears as this radiating pain or a stabbing pain that travels from your lower back down your leg. Often it can be only on one side, sometimes it can be on both sides as well, but anyone who's had sciatica would definitely know about it. And there's quite a few different causes of it. It can just be a factor of age, so it's often seen in people who are a bit older, but it can be caused by falls. If you have a fall and you irritate that nerve, disc herniation, so any sort of issues at the lumbar spine in terms of the disc can put some pressure on that nerve and cause those painful feelings. Pregnancy can cause it, even just muscle spasms. So if you're someone who has some common muscle spasms, that can really irritate the sciatic nerve. And you might have felt it before. I know I've never had sciatica, but I know that for example, sometimes when you're doing squats, it doesn't happen often, but you almost get this feeling of like a lightning bolt going down your leg. That's a nerve type pain. Whenever you have that lightning bolt feeling, like a crack of lightning in your leg or in your arm, that's normally a nerve issue happening there. And thankfully it hasn't really resulted in anything bad so far, but you'd know the feeling. If you felt it before, you know what I'm talking about right now. So the sciatic nerve, another common cause of injury, it's not super common, but another cause of injury to the sciatic nerve is when you get an injection in your bottom. So as a kid, you might have gotten injections in your bottom. It's not super common in adults, but they do it a lot in kids. And if that injection is misplaced and that big needle goes and hits the sciatic nerve, that can cause quite a bit of pain and potentially this sciatica. It can even cause, I think if it's really bad, it can cause paralysis of the leg. I'm not sure about lifelong, but I think it might be lifelong. But it's not common at all. Don't be scared to go and do that. I remember I was told that as a kid that you could be paralyzed from an injection in your bottom. And when I remember when I was young, I used to be so scared of them because the injections in the bottom, they are intramuscular. So they're quite long needles as well, normally, because they go down through the fat into the muscle. So there you go. Be careful next time you get an injection in your bum. You could end up with sciatica. Now, if you have this sciatica, or if you rupture the sciatic nerve, you can often end up with this condition called foot drop, where you just lose complete control over your limb and the ankle just is useless. It's completely rendered useless and it just flops there, and you're walking and your foot is sort of moving along like so. They call it foot drop when you can't lift your foot up off the ground. So it just dangles in that plantar flexed position for a long time. Okay, so the next thing I wanted to do with you guys, normally what we do in class now, is actually using some bits of rope and string. We'll plot some of these nerves on the skeletons. So you can read the instructions in your lab book for what we normally do, but we normally choose a few different nerves, being the median nerve of the arm, the femoral nerve, the obturator, as well as the sciatic nerve, and then we use some bits of string to put them on the models. Now, the nerve origin is different to the plexus origin, so that's something to be aware of. For example, with the brachial plexus, the brachial plexus arises from C5 to T1, but the median nerve, the spinal nerves that intertwine and combine to form the median nerve, only come from C8 to T1. So important distinction there. The nerve origin is different to the plexus origin. So have a look at these nerves. These are the ones that we're going to plot, and I've done that at home and videoed it for you guys so you can see what the final product would look like. So let's have a watch here. Now, I'm going to show you the median nerve first. First important thing about the median nerve is that it goes underneath the clavicle. So a lot of the time when we're doing it in class, people put it on top of the clavicle. It runs down here, down to the hand and supplies the muscles of the arm. So that's the median nerve. Importantly, coming from C8 to T1 spinal nerves there, you can see are blue tacked onto the yellow plastic that represents the spinal nerves on the models. Then we go down to the lower limb. So the first one I'm looking at here is the femoral nerve, which comes from L2 to S4. So L2, L3, L4. You can see that there's 3 connections there. It travels down the leg, and there we have the femoral nerve. Now the obturator has got the same origin, L2 to L4, so that's why I've just done it on the other side. But importantly, the obturator travels through that obturator foramen, so you can see it's threaded through that hole in the coxal bone there. And then the final nerve that we've plotted is the sciatic nerve. The sciatic nerve goes down the posterior side of the leg, so we're turning around to the back here. And the sciatic nerve comes from L4 to S3. So you can see all of those connections that it's made to the yellow spinal nerves, and then it's traveling down the back of the leg and splitting off into 2 at around the knee into the tibial and the common fibular nerve there. So there's our sciatic nerve traveling down the posterior side of the trunk. So that's what the nerve plotting looks like on the models. Now, our next station is looking at dermatomes. So there is, in each area of the skin, there's a spinal nerve which innervates that area with its sensory fibers, and you can see that distinction here. So if you look at the décolletage or the top of the chest, you can see that area is innervated by C4 spinal nerve. So me touching this area here, that message is getting sent back to the 4th cervical vertebrae and the 4th cervical spinal nerve, and then it's getting sent into my brain to say there's something touching me right now. And of course my brain's sending the message to say, okay, I want you to touch that too. So we've got a whole, it's inception that's happening right here. But each area of skin is supplied by a different set of spinal nerves, and you can see that here. And it's important to know, because if you're getting anesthesia for some stitches or something like that, they need to know which, perhaps not stitches, maybe something a bit more serious, but they need to know which area of the spinal cord to block so that you can't feel it. If you're getting anesthesia to have a baby, then they're going to give you a epidural to block the sensation from, you know, your lower belly downwards down your legs. So they're going to need to know whereabouts on the spinal cord to give you that anesthesia. Then also it's important for spinal cord injury. This is probably more relevant to us today, but spinal cord injury. So if you have a player out on the field and they have a spinal cord injury, you can quickly get a good estimate as to where that injury has occurred based on these dermatomes. So if they injure their neck and you feel their décolletage, again, we know that's C4 innervating this area here. And if you feel that and you say, can you feel that? And they say, yes, I can feel that. Well, then you know that the injury to the spinal cord has occurred below C4, because he can still feel this area here, and then so on. So a lot of our sports medicine practitioners use these dermatomes to reveal the site of damage to spinal nerves or to the spinal cord. And within each dermatome and within different areas of the body, there's different amounts of sensory nerves. So if we think about the areas of our body that are most sensitive, one of them is the tips of our fingers. So on the tips of the fingers, there's a very high density of sensory nerves, whereas perhaps on the back of the palm, there's less of these sensory nerves. So the next thing that we were going to do today is a 2-point discrimination test. And essentially you can take two paper clips, and with someone with their eyes closed, you either prick them with one paper clip or with two paper clips, and they have to figure out or discriminate as to whether it was one paper clip or two paper clips that they were touched with. And you'll notice in different sites of the body, people are more sensitive and can tell better whether there's one or two, whereas in other parts of the body, they're less sensitive, and it becomes harder to discriminate as to whether there was one or there was two paper clips being pressed into the skin. So let's have a quick look at a demonstration here of the 2-point discrimination test.
This next test, I'm going to take the this caliper, and I'm going to touch 1 point or 2 points, and I want you to close your eyes and tell me whether I'm touching with 1 or 2.
1, 2, 1.
Good.
2,
Good. I'm going to do it up on the palm. 1 or 2.
1, 2, 2, 1.
Now we're going to test over here. 1 or 2.
1,
Good.
2, 1,
Good.
2,
Good.
1, 2,
Good.
1, 2.
Very good.
So you'll notice there that
This next test, I'm going to...
that she got it always correct on the tip of the finger. But when he went to the palm, she kept getting them wrong. And that's because on the tip of the finger, there's a high concentration of our sensory nerves that are picking up that stimuli. Whereas on our palm and on different areas of our body, there's less concentration of those sensory nerves. So we're less able to tell, is there one or is there two things pricking into me? Even when he did them quite far apart, she said one still. So it's quite an interesting test, and you guys should try it at home with a family member or a friend. It's a very fun thing to do. You can try it all over the body, on the lips, on the cheeks, on the back, everywhere. And actually to represent the sensory nerve concentration throughout our body, there was a person who made a model of this, and they took a model of a human basically, and in the areas where there was more sensory nerve distribution, they made that bigger, and in the areas where there was less sensory nerve distribution, they made that smaller. So they've made this like creepy doll thing that's big in the areas with high sensory nerve concentration. It's called the homunculus, I think it's pronounced. You can see it here. Oh my gosh, look at that. So we can see the hands are very big because we've got high sensory nerve distribution in the hands, the lips as well. And then you can see the areas that are smaller have got less of this sensory nerve distribution. So this is often a big talking point in class, and there's often people who want to dispute the sizes of some of the features on this man, but it's quite an interesting representation of that sensory nerve distribution. Okay, let's now have a look at a movement analysis. So today we're gonna talk about the baseball pitch movement analysis. Again, I'm gonna play it for you. We're gonna have 4 minutes. I want you to try and figure it out. I'll tell you again, for the glenohumeral, there are 2 actions for each glenohumeral in all 3 phases, and you're looking at the arm that's throwing the ball only. So only looking at the arm that's throwing the ball. All right, so I'm gonna hit play now. I want you guys to try and do as much as you can, and then we'll go through it in a moment. Okay guys, so that's at 4 minutes up. Now, I hope you found that one all right. I think after doing the tennis serve last week, this one should have been a breeze. So again, at the glenohumeral joint, we saw those actions combined with some internal, external rotation there. So hopefully you picked up on those being those second movements happening at the glenohumeral joint. So let's quickly have a talk through it. So in phase 1, that arm that's holding the ball is abducting and externally rotating. You can tell by that ball coming backwards and the arm rotating outwards. And then at the elbow is flexing, so it's bending. Now in phase 1, because this is like the lifting phase, we're lifting the ball up, it's a concentric contraction, and then we can just fill in our muscle group and our agonist based off of following our rules for concentric contractions. In phase 2, again, we have another concentric contraction as we're accelerating that ball forward. So we're producing our force to throw it now. We've got horizontal adduction and internal rotation here. So horizontal adduction, meaning that the humerus is staying level and it's just coming inwards, as well as the forearm is internally rotating. So we have those two actions there. And then the elbow is extending out straight. For the phase 3, we have eccentric now. So again, we're doing our deceleration. It's going to be an eccentric contraction. So it's going to be horizontal adduction and internal rotation again. Now, if you chose something different than horizontal adduction, if you put if you put extension and internal rotation, I'd still give you the mark there. And if you put adduction and internal rotation, again, I would still give you the mark there. And for the elbow, it continues to extend. Now, again, there's a level of subjectivity to all of these movement analysis. So if you had something different and you think that you're right, I'm happy for you to come and attend one of the tute sessions this week, and you can chat to me about that. We can argue over who's right, but in the end, as long as you can explain what you saw and how you interpreted that, you'll get the mark if it is a fair argument. So always good to double check your answers if you are second guessing something. All right guys, hope to see you in the tutes. Otherwise, I'll talk to you next week.